Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to calculate molar mass but without the density. So in another video we talked about how to use density of a gas to find the molar mass of a particular gas or particular substance. And so in that video we used this equation. Remember, the density is equal to the pressure times the molar mass of the gas divided by the temperature and the R, which is the ideal gas law constant. Now you could rearrange this. If you know the density, you could rearrange it to solve for the molar mass and then just plug in the values, making sure that temperature is in Kelvin and pressure is in atmospheres. And then you can find the molar mass. But there's another way you could do it as well. You could do it in a more of like a two-step problem where if they gave you the mass of the substance and they gave you volume, you could use the ideal gas law to convert to find the number of moles. And then since they gave you mass, if it's in grams, then you would just divide grams by the number of moles, and that would give you grams per mole, which is the molar mass. But you could, if they gave you the mass in grams and they gave you the volume in liters, then you could just divide grams by liters, and that would give you the density of the gas. And then you could use this formula here. So either way is fine. So let's try it the other way. So in this problem, we have a sample of a gas. Oh, the first thing we should always do is check to make sure we're not in STP, because if we're at STP, then all we need to do is use the density is equal molar mass over molar volume, and the molar volume at STP is 22.4 liters per mole. So 1 mole of gas is equal to 22.4 liters, and you could use that to find the molar mass. That would be a simple way. So check to make sure you're not given STP conditions. Remember, standard temperature and pressure. Standard temperature is 0 degrees Celsius, which we do not have, or it's 273 Kelvin. And the atmospheres is 760 torr, 760 millimeters mercury, or 1 atmosphere. And here we do not have 760 millimeters, so we're not at STP. So, but that's okay. It's not going to be that hard. So what do we need to do? We're gonna use the ideal gas law first. So we are given liters of the gas. We are given temperature. But we need to convert temperature to Kelvin. Okay, so 55 degrees Celsius plus 273.15 is going to give us, let's see, that's going to be 328. So 328.15 Kelvin. So let me double check. So that's gonna be 328. So here we have Kelvin. Now we have to do our pressure. So pressure needs to be in atmospheres because of our R value. Remember, the ideal gas law constant has the units of atmospheres as for pressure and Kelvin for temperature. So we have 886 millimeters of mercury over 1. 760 millimeters of mercury is equal to 1 atmosphere. So we can use that as a conversion. So I'm going to put 760 millimeters of mercury on the bottom and 1 atmosphere on top. Millimeters of mercury will cancel out. And now I can calculate the pressure in atmospheres. So 886 divided by 760 equals, and that's going to be 1.1657. 1.1657 atmospheres. Now I gotta keep track of my sig figs and decimals. So since I added, I need to keep track of my decimal places. So least number of decimal places. I have 2 here. I have 0 here. So I'm only allowed up to the 8 for sig figs. Here it's the least number of sig figs. So I have, this is exact. One atmosphere is 7 to 16 millimeters mercury, so I can ignore that. So I'm looking here at 886. So that's 3 sig figs. 1, 2, 3. So that's the last significant digit. But I'm going to keep the digits so I don't get a rounding mistake. So now I can plug into the ideal gas law. So PV equals nRT. I want to solve for moles, right? Because if I can find the moles, then all I need to do is take the grams, divide by the number of moles, and I get my molar mass. So I have PV equals nRT. If I divide both sides by RT, then I get N by itself. So N is equal to PV over RT. So now I can plug in my values. So I'm going to plug in pressure. So N is going to be equal to 1.1657 atmospheres times the volume. The volume, where's the volume that they gave me? Where's the volume? I thought they gave me volume. It's volume, there it is. 0.225 liters over R, which is 0.08206 atmosphere liters over mole Kelvin, and then multiplied by the temperature, which is 328.15. So 328.15.15 Kelvin. And so now atmospheres cancels out, liters cancels out, and Kelvin cancels out. So now I'm left with moles. So if I do the calculation, that will give me the number of moles. So I'm going to multiply 1.1657 times 0.225 divided by 0.08206 divided by 328.15 equals, and I get 0.00974. So the number of moles is 0.00974. Let me double check. 97408. Okay, so that's the number of moles that I have. Now let's check my sig figs. Now, if I remember, so I had 6 here, so I'm only allowed up to the 6 for there, and 8 here. I'm only allowed up to the 8 there. So for this, I have 3 sig figs, 3 sig figs, 4 sig figs, and 3 sig figs. So the least number is 3. So 1, 2, 3. So the 4 is my last sig fig for the number of moles. But I'm going to keep the rest of digits to keep myself from getting a calculator mistake, because I still need to use this to find the molar mass. So now that I have moles, they gave me mass, so I divide the mass by the moles to get the molar mass. So let me do it over here where I have room. So I have 0.311 grams divided by 0.0097408 moles. So now if I calculate that, so I'm going to take 0.311 divided by my answer from before, the moles, equals, and I get 31.927. So 32 point, what did I say? 927. But that's grams per mole. So now let me check my sig figs. So here I was only allowed 3 sig figs. So I'm only allowed up to there. And I have 3 sig figs here, so my answer can only have 3 sig figs because that's the least number of sig figs. So 1, 2, 3. So I cut it off after the 9. This is a 2, so I don't have to round. So the answer is 32.9 grams per mole. Okay, I hope that was helpful. Let's do the next problem. So really quickly, so here we have the mass of a sample of a gas is this. So they gave us the mass, and they gave us the volume in liters, they gave us temperature and millimeters mercury. So it's the same thing. So we'll convert the grams to milligrams to grams. So we have the equality of grams and milligrams. So I put the 1 with the milligrams, the prefix, and milli is 10 to the negative 3, so the prefix multiplied goes with the base unit. So if I calculate, that's going to be 827 milligrams over 1. Okay, 1 milligram on the bottom, and then I have 10 to the negative 3 grams on top. Milligrams cancel out, and that's going to give me 0.827 grams of this gas. Good, so now I have grams. I have liters. I need to convert temperature to Kelvin. So 88 degrees Celsius plus 273.15. That's going to give me 361. So 361.15 Kelvin. I hope I calculated that right. And then because of sig figs or decimal places, this has 2, this has 0. So I'm allowed only 0 decimal places. So that's the last sig fig there. Okay, and lastly, I have 978 millimeters mercury. So 978 millimeters of mercury, and I gotta convert that to atmospheres. Again, 760 millimeters of mercury goes on the bottom, 1 atmosphere on top. Millimeters of mercury cancel out, so let's calculate what that is. So I have 978 divided by 760 equals, and I get 1.2868. 1.2868. Let me double check. 1.2868. And so this is exact, so I don't need to worry about that. So I have 3 sig figs, so I'm allowed 3 sig figs. So that's the last one. So now everything is converted into the proper units. Now I plug it into my ideal gas law. So again, I'm going to solve for N, so it's PV over RT. So the pressure is, this is atmospheres, so pressure is 1.2868 atmospheres multiplied by the volume, which is 0.270, 0.270 liters, divided by R, 0.08206 liter atmospheres over mole Kelvin times temperature, which is 361.15 Kelvin. And so atmospheres cancels out, Kelvin cancels out, and liters cancels out. So I'm left with moles. And so now all I need to do is calculate the moles. 1.2868 times 0.270 divided by 0.08206 divided by 361.15 equals, and I have 0.0111723, and I'm only allowed, so here I have 3, so I'm only allowed 3 sig figs. And so now all I need to do is divide grams by moles. and I get the answer. I hope